Okay, here we go, another relativity question. We're looking at rocket R traveling away from an observer with a speed of 0.8 c. We've seen that speed before. And we've got 4 world lines. What's the correct world line? All right, this is quite a nice question. This is one which is using the ideas of angles and appropriateness of those angles. So if you notice here, all of our world lines, our possible world lines, are a different angle theta. So let's review that. One thing to remember is if we've got a world line, say this blue line here, we measure the angle relative to the vertical axis, relative to the y-axis or the CT axis, and that's that angle here. Now what you should be aware of is that the tan of that angle, which is the opposite over the adjacent, is equal to the ratio of the speed to c. So in this case, tan of theta is v over c. We're told that this v is 0.8, so we're going to take that and we want a 0.8 here. Okay, what we're looking for is a tan theta, which is equal to 0.8. And to do that, all we're going to do is use the image that you can see on the screen. Take the example of A. If we go for, in this case, we've got a negative x. Okay, we're going to do opposite is minus 2. Adjacent is going to be 2. And so therefore, we've got tan of theta A is opposite over adjacent, minus 2 over 2, which is minus 1. Okay, do the same for B. Okay, in this case, I've gone for, I can show you the working here just now, minus 1.6, that's this bit here, divided by 2, and that's a minus 0.8. In the case of C, let's try that one. Okay, well, we're going to have 2 over 4, which gives 0.5, and then finally, we've got our last one here, which is going to give us this distance over this distance here, opposite, which is 2 over 1.6, which is 1.25. Now, we can talk about which ones of these are possible. However, you'll notice that none of our answers exactly match. The best one there is actually our answer B. Now, why is it the minus 0.8? Well, because remember, we are moving away from us, okay? And that therefore we have a minus sign, which then allows these two objects to be moving away, okay? Really what we're looking for is an angle which is equal in magnitude with this ratio, and so the 0.8 is absolutely fine. Okay, one thing to pay attention to here is that the maximum angle there, which is possible, is our theta A, because theta A gives an angle of 45 degrees, and that would be the angle made by light relative to the observer. Anything more than that would be not possible.